tomorrow, no, we're moving on Thursday. Tomorrow is a lab, and then we move on to chapter 11 on Thursday. So. All right. Hydrates. What a hydrate is, it's a solid in which water molecules are trapped. Okay. So essentially, you can kind of think of it like if this is your molecule, you have water molecules that kind of get trapped or attached to these molecules. Okay. And some of them, there'll be 4 water molecules. Other ones, there'll be 5. Some, there's only 2. It just varies. Okay. And those water molecules become part of the crystals, and they're called water of hydration. And a hydrate is a compound with a specific amount of water molecules bound to it. Right? You can heat this hydrate up, and those water molecules will come off as water vapor, and it will leave the compound by itself. So you can add heat and separate the water off from this. Does that make sense? You've seen these hydrates like in real life. When you've gotten a package of something that's been shipped from somewhere, a lot of times it'll come with a packet in it that says "do not eat." Have you seen that? The purpose of that packet is it has one of these hydrates in it, and it's going to soak up any water that might be in the environment. Because oftentimes these things are coming overseas, like literally over the sea in a big cargo ship container. And a lot of times it's a very humid environment. They don't want water getting in there because if there's any mold spores anywhere, and mold spores are microscopic, like you cannot see them, okay? Then those mold spores can start feeding on that water, rehydrating with the water, and then they spoil whatever goods it is. And that could be food, it could be a new jacket, it could be furniture, it could be all kinds of different things. So you will commonly, especially in clothing and shoes, you'll commonly see those little packets. One of the other places that you might have seen these is if you've traveled to any place that's kind of a hot, humid area. What is it called? You can buy this at Woodman's. I got to remember what it's called. These are kind of the things that you'll see in different packages, but you can buy them at Woodman's. What is it called? When I see it, you guys, I'll know it. I can visualize even what it looks like. I hate that. I've even bought them before. And it's just going to be all water stuff. Basement. Boy, they're really after the finish, aren't they? I used to buy them all the time when we went to Mexico. I can't remember what the name of it is. Anyway, you can buy them. You can buy them down in the grocery store at Woodman's. Diapers, baby diapers. they work with this. So if you have ever like had a baby, that you can actually open it up like between the layers, there's this powdery kind of stuff in there, and that will absorb the urine and water from the baby. And if you've ever had like a baby diaper that you've had to change before, it almost feels like a gel in there once the baby's peed in it. You know what, you're not actually touching the part that they peed on, but on the outside, it'll actually feel kind of like a gel. That's from this powder that's absorbed the water. So those are just examples of hydrates. Okay. So the number of water molecules written with each is followed. You put a dot here and then however many water molecules you have. Mass of water must be included in your molar mass calculations. Your atomic mass, formula mass, called by several different things. Okay. The stuff that you add up on the periodic table, you have to add the water in. Okay. Here are, so compounds can be found with a variety of water molecules. So you could have a monohydrate with one water, di, tri, tetrahydrate, pentahydrate, all the way up to 10. Okay. You've seen these prefixes before. Remember? They're the same prefixes that you used when you were doing your covalent naming. To analyze a hydrate, the water has to be driven off. You have to heat it and drive it off. To find the mass of the hydrate before heating and then after heating, and the difference then is going to be the water. So here we have magnesium sulfate and we have water. So these work similarly to the empirical formula problems that you did yesterday. So if you were given percentages, step 1 is to assume that you have a 100-gram sample. Step 2, convert those percentages into grams. Boom, done. Then we are going to figure out the moles of this. So I'm going to figure out moles. I'm going to divide this by the molar mass of magnesium sulfate. So magnesium 24.3, a sulfur at 32.1, and 4 oxygens at 16 each. Gives me a total of 120.4. So that gives me a total mole amount of 0.405 moles of MgSO4. Then I need to figure out my moles of water. So that is 2.84. Now, if these numbers, the water should always be equal to or greater than this number. Because remember what a hydrate is. It is a compound with water stuck on it. So the one, you have to have one of these for multiple items of this. Does that make sense? So this number, if it's equal, then that means that you've only got one water attached to it, which is fine. Okay, so it can be equal to, or the water has to be greater than this amount. Does that make sense? Yeah? Okay. All right. So the next step then is we are going to divide by the lowest mole amount. So 0.405, 0.405, This, of course, is 1, and this is 7. So our formula here is going to be MgSO4 dot 7H2O. The name then is magnesium sulfate heptahydrate. Easy enough?
Actually, the water having to be equal or greater to doesn't make sense to me. I mean, in this case, you can see why. But...
So the whole idea of a hydrate is you've got one of these molecules, right? And you've got water stuck to it. So you're always going to have one of these, and then you're trying to say how many waters you've got stuck around here.
Oh.
So, yeah.
Okay, that makes sense.
So this is, so we've got 7 waters stuck around this guy. So this is always a ratio of one of these, and then you're telling how many of these are stuck onto it. So this value always has to be smaller or equal to. If it's equal to, then that means you've just got 1 water stuck on there. Otherwise, it's got to be greater, which means you've got more than 1 water stuck on there.
I was thinking as in terms of size.
No, don't think of it as size. It's items, it's number, it's quantity. All right, percent by mass of anhydrous sodium carbonate. You need to know the sodium carbonate. And this is in decahydrate. So deca is how many? 10. Yeah. 10H2O. All right. They want to know the percent mass of the anhydrous. So that's this stuff in the whole thing. So this is the whole, and they want to know this part. So we need to figure out the mass of this. So 2 sodiums at 23 each is 46. Plus a carbon plus 3 oxygens. That's 106 for my mass here for the part. Now we're going to figure out the whole. So I need to add in 18 times 10, which is 180. So that's divided by 286 times 100. Is that it? That's it, I think. Yeah.
Where did you get the 286?
So that's the mass of this, which is 106, plus 10 of these. So 18 for water,
Okay.
times 10 is 180. So the whole is 286.
Oh, you just, okay, then you, okay, I see.
Okay, good? Pretty good? Okay, so I'm going to hand out your quiz for molecular empirical formulas and have you do that. And then I'm going to try to get through the labs for those of you who brought labs up for me to to check. I'm going to try to do that as you're taking your quizzes, okay? That's my goal. We are on empirical molecular.
Could you check my lab?
In the file.
Also, I was going this thing, so I don't know if you just want me to turn it in tomorrow and then.
The lab or the?
Yeah.
You're not ready for it?
No, I am ready, but like if you aren't ready for it next hour.
Okay, I gotcha. Okay. All right. Did you watch the video last night so you can take the quiz today? Okay. I assume you're not taking that.
I'll give it a shot. What's the worst I can do? That's gonna be taken.
I love grading papers, so yeah, why don't you just, you know. Can you get this to Ray? And then you guys have homework for hydrates tonight too.
Correction time, like the other quizzes.
Can you do this to Ava? Can you go by? Ava, can you give this to Ava? Thank you. So Ray, it's just the green.
When we're writing it out, do I do like that, like for this multiplying?
Yep.
Okay.
It's not really multiplying though.
It's just
That's how they denote it, but it's not really a multiplication.
Okay.
What was the problem with this one? Was it just not the unit? 'Cause
No.
added the unit. I plugged it in to double check.
I have no idea. I have no idea what was wrong with it. I don't know in my brain what I saw.
The atom ones I did fix, and then there's one more that I fixed with the 1022. And that's it, I think.
I'm sorry, Merrick. I don't know. I can't tell you.
That's alright. I had no idea I was gonna give it like a shot in the dark.
Just throw it away. I don't even want to. Yeah, it's not even. Yeah, you're shooting in the dark. You're right. Go listen to my video. You got headphones?
Yeah.
Can I ask you some questions? Yeah. Because we're running out of time here, I probably should just ask, what am I doing wrong here?
Nothing. I said that you just needed to look at the green. The green.
Oh, just the green? Okay.
That's what I said. I just told you. Look at the green.
Sorry.
This is the one.
It's 2 pages. Sophia. Alex, he must speak to Ellen. Izzy and Noah, and your labs are good. Yeah, that's better.
Okay, I think I'm lost.
All you have to do is take this and divide by that.
That's it?
Yeah.
Okay. Then I guess I have the answer. Wait, why does it say atoms?
Because that's how many atoms it is. You have said right here that this is not moles. This is in one atom. This equals
Oh my goodness.
one atom.
Okay. Got it.
Noah, pass this back to Haley. Right here. Thank you. All right, I'm caught up in everybody from this hour. If anybody else needs me to look at their lab, I'm on to 7th hour otherwise.
Before I go into station